In this video, I will explain you motional EMF due to a rotating rod. So in the previous example, the rod was in a linear motion and that created an EMF of, what is the value? BLV. So this is due to linear motion. Now the rod is rotating at one end fixed in a magnetic field. So in this example, see, from this position, the rod will now come back to its original position. After what time? After a time period. What is time period? Time taken to complete one circular revolution or simply a revolution. So in a time period, what is the total magnetic flux linkage with this rod? That is, in that time period, this sweep a total area of, what is the area? Area of the circle. So in this time period, it will sweep a total area of the circle, and that is equal to pi L square. Now in the same time period, what will be the total flux linkage? If the area is pi L square and if the magnetic field is B, then the value will be B into pi L square. Because I know that magnetic flux is equal to BA cos theta, and I know the value of magnetic field at that point, and area is pi L square. And why I haven't considered cos theta? Because the area I am considering is this one and its direction will be perpendicular to that. Now this is the direction of area, and that when considered with the direction of intensity of magnetic field or magnetic field line, that comes parallel and angle is 0. So theta is equal to 0. So cos 0 is equal to 1. So this will become P into A only. So B into pi L square. So as per the equation, EMF is equal to minus d phi by dt, and this is equal to minus d by dt of. So here in this case, we don't have to consider d by dt parameter because we can simply get the value of total change in flux. What is the total change in flux? See, minus of phi 2 minus phi 1, right? So here the total change in flux for this rod is this one. From 0, it has got a total flux linkage, or this has cut a total flux of B into pi L square. So the change here is pi L square into B. This is the change. And time is equal to dt can be taken as, or time can be taken as the total time period. And time period can be written as 2 pi by omega. This we have learned, right? So simply this equation can be made in this way. Change in flux divided by change in time. Change in flux divided by time, total time period. What is change in flux? Pi L square into B divided by, what is time period? 2 pi by omega. So pi will cancel and omega will come to the top. So that will give a value of induced EMF as half B L square omega. Omega will come to the top and half will be there. So half into BL square omega is the equation. A rotation of induced EMF due to a rotating rod. This is very, very important. And what is the application, you know? See, Earth will be having horizontal magnetic field. Let's say at this position, horizontal magnetic field is in this direction, and let's say vertical magnetic field is in this direction. So horizontal magnetic field is into the plane. Now when I am cycling through this road in a straight line, my tire is made up of number of spokes, right? There are a lot of spokes, and this is now cutting the horizontal component of magnetic field. So what will happen? There will be an induced EMF across each spoke. So this is one spoke. Now across this there will be an induced EMF, and the value will be half into here horizontal component of magnetic field into length of the spoke into rotation. I mean the velocity at which we are going. So you can convert velocity and omega with this equation. V is equal to r omega. So say for example, if you are moving at a velocity of 5 meters per second, that can be, from that equation we can get the value of omega. Omega is equal to V by R. So if the spoke is having half meter length and V is 5 meters per second, then this is 5 divided by half, the value will be 10 radians per second. 10 radians per second. So similarly, you can get the value of omega and find horizontal component of magnetic field at that position and substitute the value of length, that is nothing but radius of this tire, and substitute all the values here. We will get the value of induced EMF. This is a question that is asked several times in your CBSE examination. So the same equation, in the case of cycle, it will be E into half B horizontal component of magnetic field, because it is cutting horizontal component, right, not vertical component, and L is nothing but radius of the tire, so that will be R square, and omega, if velocity is given, you can substitute omega in terms of V by R. So this will become half into B R V. So this is one equation, this is another equation. Whichever the values it is given, you can get the EMF using the right equation. Now next question is, in the case of spoke, in the case of cycle tire, there are number of spoke, right? So if there are 20 number of spoke, what will be the net EMF? See, net EMF, there won't be any change. See, we have learned 2 volt and 2 volt and again one more 2 volt. If they are connected in parallel, what will be the effective EMF? That will be the same. Similarly, we are connecting all positive to one end, all negative to one end. So these are parallel connection of battery. So whatever the EMF induced in one spoke, it will be the same with all, and the net EMF will be the same. So find the value of 1. To confuse you, they may ask, there are 20 number of spoke, what is the net EMF? It is the same value that induced in one spoke. And another question can be, they will give you the value of net magnetic field, and they will also give the angle of declination or dip at that point. So using dip, you can find the value of horizontal component as B cos delta, and B sin delta will be vertical component, B cos delta will be, see, B cos dip is equal to horizontal component. So here in this equation, you have to substitute the value of horizontal component. If net magnetic field is given, don't substitute that, because net magnetic field will have 2 components, and out of that, cycle tire is cutting only horizontal component, not the vertical component. Okay, thank you.